Yeah, second part of unit testing with SUnit, building upon what we did last time in the first part. I hope you guys remember the most important parts. If not, you can always rewatch it. And today there's no theory, just developing, part together and part on your side. And this is the agenda. So today we will do some live developing. So basically, based on the file out business traveling training that I sent around yesterday, we will extend this a little bit. That means I will do that and you guys will watch. And then I will send around the version that we just created for everybody, because in the given time we have, it won't be possible for everybody to retype everything, of course. That will take too much time because there's quite something to develop. So I won't rush, but I also won't make too many breaks. So you have to tell me if there's something that you don't understand. The hands-on part is this extension of the scenario. So I will ask everybody to create some unit tests and complete the code. And after 15 minutes, I would like to review one of the solutions. If there's no one volunteering, I have a way to find someone. So just for you to know.
Could you maybe, you sent something, you sent a diagram yesterday and a Smalltalk file, and could you tell me what to do with it? I just have it. Okay, but where? In YCAT.org?
No, you have me to go to the
file browser.
Yeah, to the F2.
F2.
And now F2.
Just file in package Visual Works.
Okay, it's very far away. You can go on, sorry.
So we're looking here at this scenario that I sent around yesterday. And what is this about? Well, salesmen, managers, they like to travel, or maybe they don't like to travel, but they have to travel. And why or how are they choosing their destination? Well, maybe you would think it is for business reasons, but in our case, it is not. It's just for convenience reasons. So they want to travel to the warmest city that they have in their list of preferred cities. So we're going to use a web service to find out where the warmest place right now is, so that the employee can travel to that place. And basically for this, we have this city travel choice maker that is going to find the warmest city for us, requesting the data from a web service. Then we have a proxy on our client, on our side, for the response, the weather report response. And of course, there might be some error that we want to throw. And the city class is simply representing the city. So this is a very anemic object that only has two members. And a few of those very basic classes and methods I've already created and sent around in the file out just to save time, because we want to focus on unit testing. And we don't want to focus on creating instance variables and getters and setters. So that's why I already sent that around, and we're going to extend it. For example, the city travel choice maker is not existing yet. I will create a few unit tests together with you, and you will then be kindly asked to create a few more later. And this is obviously not a lecture or lesson on clean code or good design. So I will not focus on explaining the design as such, and I haven't created a design that is, let's say, a perfect design, but I also haven't created a design that is the typical one large method, as you can see, because actually a better design is something that comes from testing or testing in mind, and which is why I've chosen a design that allows us to explain where testing can help us. More about this later. For now, we're going to the code, and what you see is exactly what I just described. We have the very basic city class. We have this choice maker with so far only the HTTP client and an initialization method that what it will do is we see here we have these cities and in the initialize method we are just instantiating the cities to be an ordered collection. The weather report response has the city name and the temperature in Celsius. Again, just two simple numbers, nothing special about it. And the weather report response error is just a class inheriting from error, so exception. That's all. Now, one thing I would like to basically show is how we can get data from these web services. So now there is a class in Smalltalk in the library, which is the HTTP client, and it has a class method that we can call any URL basically, and we're just taking this web service here, just pasting the URL, and we see we get a result. Now, the next step is we can say this is our response, and now in our own code, in our own library, we have a JSON reader, and it can read from a stream. And to get the stream, we say response contents stream, I believe was the method. Let's see if that's true. Yes. So now we see we have our response, a dictionary which is exactly what we have seen here. This is exactly the same result, just that our JSON reader has created Smalltalk objects based on this result. And what is interesting to us is this list, where we have now two entries, which is because this guy is expecting us to be a little bit more specific. If we say London, UK, then we should only get one result. Yes, we do. Because if it finds more than one result, it's just adding those results. So it can be based on an accurate search or a like search, but this is not about this web service, this is just to explain. Now in some systems, and I won't say in which, but in some systems, you might just find one method on a super overloaded class that would be something like, give me the warmest city, and you would see exactly this code, maybe with a parameter of city names, and this is what you would return. Now this is not the code quality that we're looking for, and this wouldn't help us understanding testing, which is why we have this structure, this design that we see here, and we're going to use this, but in a slightly more extendable and reusable design. Now, as I said, the weather report response is our proxy class for this result that we just saw. So the first thing we want to do is we want to say we want to be able to instantiate such an object from this JSON stream that we just saw. So I'm going to type a little bit and explain in a second. So this little object, we're going to read from the JSON stream that we're getting. So now we have our parsed JSON response, but we're not continuing in the same method, but we're calling another method that we will create in a second. Why? Now this is one of the advantages of having testing in mind. And you may note that I'm not saying test-driven design, I'm just saying testing in mind, because test-driven design is a topic that is being discussed quite controversially, and some people are for it, others are against it. This is not, again, the topic of this of this training, but what I want to say is if you think about your development and you think about the, testing, then you might end up with a few advantages and a cleaner design. One of them is you will have smaller methods, because the problem here is we have two dependencies. The one dependency is that we're actually calling a static method, a class method. Now, this is very bad if we want to have, you remember from last time, stub mock fake objects, because this is going to make this pretty difficult. Whereas if we use instances with dependency injection on version of control, we can inject another instance. Now, if we say anyway we go for this static class, then we can at least say the result that this guy is giving us, we are extracting in another method. So we can write a unit test that will parse this input into this method. So at least we can write a good unit test for this part. And we have, as an automatic result, as I just said, we will have smaller methods that with reduced dependency. This is a new method, I know, and we're going to create it right now. So from JSON structure, and from JSON structure looks a little bit different. Now what we're getting is basically a dictionary. We just saw that our JSON reader is providing us with a dictionary. Now what we will need is the weather details from this response. And we saw earlier, and I know that by heart meanwhile, that it is an element called list. Now what we want to do here is we want to be able to respond to the case that this is actually missing, which is why we have a custom exception class that we mentioned earlier. Because if we just use error in general, we won't be able in the unit test or anywhere else to distinguish between an error that we expected and an error that we don't know. So this will help us to understand much better what is actually wrong. The method, of course, can be better than this, but this doesn't help us to understand unit testing better. This is actually then a matter of learning how to write exceptions. Now, another thing we want to check is whether actually there is only one result, because earlier we saw we might have more than one result, which the way we're going to write this is not expected. So we're saying if the size is not 1, so either no or more than 1, we're also going to write or throw this exception. And again, should have a more customized text, but that's not important at this point. And if not, then let's say, okay, our weather details is actually the first element of this list. Details first. So now the weather details is not the collection anymore, but actually the weather details. Now, there was another section in that was called a main. So our JSON response contains a main key. And in there, we have the temperature. So main details at temp. And the last one we were interested in was the city name, which is weather details at name. Okay. So we're going to need those guys here. And the last step that's missing is we actually want to return our instance from the weather report response. So if we have our client-sided proxy from the web service, now we are able to create one instance from this proxy. Let's say our city name is the city name, and our temperature, I think it was Celsius in this case, is the temperature. No. And of course we need yourself. And this instance is not there. Okay. So I guess everybody understands this concept of a factory method that will create an instance and return it based on some input, right? Mm-hmm. Okay, because this is what we tried to do here. All right, so now we can instantiate such a proxy instance from a JSON stream. And we can test that by typically writing a workspace, but no, we want to write unit tests. So let's create a unit test. And this unit test, as you know, should inherit from test case. Let's see if that works. And we call it weather report response test case. Okay. The second thing we are going to need is the weather report response test resource. And again, we want to have a test resource. No, test resource. Okay. Since we will want to test, in this case, an invalid and a valid case of a JSON response, we are going to need a valid JSON structure and an invalid JSON structure. So, and to make it explicit what this is, I will call this invalid London JSON structure, meaning that we're expecting something for London, some weather report for London. And the second thing is we want to have a valid London JSON structure. Let's create these guys, and it's always a good idea to say what we're expecting. This should help us, or others much more, to understand what this is about. And we are going to need to set this thing up and tear it down. And in the setup part, we want to say self-valid London JSON structure. Okay, let's just copy the one we got from the web service. But we need to modify this. I have one. Okay. And the same for our invalid London JSON structure, which of course can be anything. Let's just call it Paris. And in the teardown, although from a language with a proper, garbage collection, you actually don't need to do this, but let's just do it for the sake of example. We set this to nil. Okay. And now it's set up and torn down. You probably remember that we will also need to go to this test case and say that one of the resources that we have is what we just created. And this time we're trying to do it correct with weather report test resource. Okay, now let's look at the test cases we can actually write. I guess one of the easiest to do would be to say we test for a valid JSON structure. So test valid JSON structure. And this means we just want to, or this could mean we just want to see generally whether this weather report response is returning an expected result in basic terms. So that means all we want to do is we want to say if we call this guy with the weather report response test resource, that's a long name, current, remember it's a singleton, so we get the instance, and we say valid JSON structure, then one way we can find this out is we say, okay, the class that we're expecting to be returned is the weather report response. Okay, valid, of course we need to say valid London JSON structure, because that doesn't exist. And the weather report response is wrong. No, it's not. Okay. Now, one way to instantiate this that last time we didn't look at is actually the following. We have a way from the framework to say any method that starts with test is going to be run and considered as a test. And this can help us to run multiple tests in one test case. And this also can help us to make it easy to use the same resources. Now there is a method for this that is called build suite from selectors. And this guy is actually going to collect all the tests based on the methods that start with test. Okay, that worked. And now test suite, all we need to do is call run. And see the result. Okay, we have one error. Now the error is, it's saying in test valid JSON structure. So let's see what is wrong. Test suite run. So where is our error? Okay, now the problem is that a dictionary is not a dictionary. Aha. So now we notice something. We actually notice that by writing the unit test and by looking at custom exceptions, we should check something else, because we should check the dictionary is dictionary. If false, then we can again throw our custom exception. And later, in another method that we're going to write, we can check that we're actually expecting this exception in such a case. But for now, let us correct what actually caused this error, and this error is the following. In the setup, we just defined a string here. So actually, we need to say JSON reader read from, and the thing is, because this guy is expecting a stream, we will need to say read stream on that string. Okay, let's see. That's okay. Suddenly we got a passed. So it worked. All right, now let's test an invalid JSON structure. And in this case, we are actually expecting an exception. So self should, and then we're providing a block with what should actually be called. And we're saying weather report response from JSON structure, and then again we're getting our weather report response test resource current, and then we're getting our invalid London JSON structure. And in this case, we say this should raise a weather report response error. Now let's remove it. Now we should get 2 passed and actually 2 tests. Let's see if that is actually true or we have another error. 2 passed. Okay, one other thing I want to show before we move on is that we can actually also use the case of deny. So for that, we assert and deny are basically just working based on Booleans. So you have assert equals, so that means the result equals something else, but you also have assert means you're expecting a true Boolean, and deny means you're expecting a false Boolean. For that, we can actually just go to this guy and change this a little bit and say is valid JSON structure, and basically in this case just instead of the exceptions we can return false, false, and again here we return false, and ultimately we can just return true. And of course, yeah, we don't need all those. Of course, we should call this method then here instead of rewriting the code 2 times, but again, not purpose, not purpose of this meeting or this training. So the name that I thought of is a little bit long, but JSON is invalid, so at least it tells you what we're actually checking. So we check if the invalid JSON is actually invalid. Self-deny, what I just said, whether report response is valid JSON, and you're starting to remember test resource current invalid London JSON structure. Okay, I said is valid JSON structure. Okay, and another test. 3 passed. So just for fun, if we return a valid JSON structure, we should get 1 fail, and we do. Okay, but we want invalid. Now, let's go to the last point before we're actually going to go over to the next task, which is the travel city choice maker. Now, the first thing is very simple. We say add city, a city. So we have the ability to an instance of this travel city choice maker to add a list of cities, to later make our choice where to travel to. The other thing that we want to have is travel to warmest city. So the method that is actually the first one that is dealing with our domain. So we want to travel to the warmest city, as we said earlier, which is a nice reason for picking a city. And for this, I would like to first say, give me all the weather data for the cities that I have. And again, let's create another method where we do that. Yep, proceed, proceed, proceed. So weather for cities should return for us all the weather for all the cities that we have. Now, let's just say our city responses, which is our weather report responses, ordered collection new, of course, it should be the amount of cities. No, it's misspelled. Temporary, correct spelling, ordered collection, proceed. Cool. And something that we're going to need is we're going to tell in the request which is actually the city that we're looking for. For this, I'm going to make a little template where here we see London, UK, but in this case, I want to say this depends on whatever city we have. So I'm going to replace these values with the city that we have in a second, basically in the next line. And we're going through our cities. So each city, we say we have our request and we have our response for a city. So our request is based on our template, response city template. Copy, replace all. So this will replace our city part. Almost. with the city name. And the second part is we replace the country code with the country code that we have in our city. Now, response for city will tell us to go to our HTTP client and get and say request. And just one remark again, that this HTTP client that we see here is an instance method of the class. And that makes sense because when we test, we might want to replace this with a fake object. So we can also pass it as a parameter to the method. That could be another option. All right. The last step we need to do is we add this to our city responses. So weather report response from JSON stream response for city, and then, as you remember, we have this method content stream. And we also will want to make sure that we close our HTTP client. And finally return our city responses. So this method will return our city responses. So that means every city with the weather data. And we're only interested, as we saw earlier, in the city name and the temperature in Celsius. Okay, going back to the method that calls actually all this, we want to sort them. And actually, we don't only want to sort them, but we want to get the warmest city. So from this response, we create a sorted collection, A, B, and sorting means A temperature Celsius, again, Celsius is greater than B temperature Celsius. And then all we need to do is return sorted cities first. Okay, we're done. Done in the sense of we've developed this together. As you saw, I wrote tests for the weather report response. So when we're instantiating weather report response based on the result from a web service, we have some basic tests for valid and invalid JSON structures. And as a second step, we have developed the logic that will return for us the warmest city that someone wants or might be able to travel to. Or from the cities that he might be able to travel to, we find the warmest. We have not written any unit test for this part, for this method, and for this logic, which is what I would like you to do. I will send you this version with a few more unit tests that I skipped for time reasons now, and I will click on send. And while the emails are arriving, I will quickly continue with the presentation. So that was the demo part, and I just would like to repeat a few of the advantages that I see when we have testing in mind. We have a dependency reduction. So again, that means we usually realize that we cannot rely on singletons or static methods because that will make testing hard or almost impossible. We tend to validate parameters and outputs. You remember we had custom exceptions, and in the test we will want to check for certain exceptions to occur, and that automatically makes us test and validate input parameters and hopefully also the output. And yeah, by that we get custom exceptions for free. We have smaller classes usually and also smaller methods, because if you have a method with 8 code paths, the unit test is going to look quite funny. And typically, testing in mind will help you there. Now to the hands-on part. I would like, as I said, everybody to write at least 2 unit tests for this logic of traveling to the warmest city. And at the end, I would like to spend a few minutes to discuss one solution from somebody.
What I heard is that basically the task was the city traveler choice maker tried to make some tests. I don't know any parameters, so I started to check what is this. So it has basically 2 methods, that one getting all the cities from a web service, and the one that picks the one that has the temperature value is the highest. So first I started to write one, whether we get actually something back, so whether for cities. I check the cardinality, whether we get something, and it should give me an assert if it's basically 0, I mean the list. That was one. And the second that I started to write is to somehow validate whether the warmest city is the warmest city. By basically using what the travel to warmest city has. I mean, like kind of code with this, not with the same way with the sorted collection. And now I was about to write there something. So, but that's all I did. So.
Okay. Well, thank you. Yeah, to make this not any longer than necessary, I think what is important to test and to consider and to learn is we have unit tests that deal with format validation, that deal with input validation. So you mentioned that, for example, the cardinality is 1. So that's an example. And this is more, let's say, yeah, on a programming level, on a value level tests. But what is always important, and I think that was the other test you mentioned, is that we actually test the business logic. And the business logic here is that we want to find the warmest city. So any test that has only one city will not test the business logic, because we want to verify. It will test something, but it will not test the business logic, because we want to verify, is our logic actually finding the warmest city amongst all the cities that I give it. So these aspects are important to test. If anybody wants, I can send a default solution, standard solution later. But yeah, that's it.
I assume that you implemented a mock class for this HTTP client, right? Okay, that was what we started and what we did basically. We created an own HTTP client. Ours was very stupid. It was just giving exactly one, whatever you put in the get, it will just give you something. But I mean, to make it better and to test the business logic, we at least had to make sure that it will provide 2 different values depending on what you test. And then, I mean, it could do something like, okay, if the time is, okay, for the first get, we will definitely get the information from London, and for the second get, we will definitely get the information from some other town, and then with different temperatures, and then we can make sure that the highest temperature basically is, or the town with this higher temperature is basically returned from this method. That would be one approach. Okay. If we had enough time, we had done.
Not enough time. Yeah, we'll remember that for next time. Okay, then that's all. I'll try to send the default or standard solution later. And thanks everybody for attending and trying. For me, it was fun creating this, and I hope it was a little bit of fun for you extending it. And yeah, I guess see you next time.
Okay, thanks.